Hello everyone. So today is going to be our day 37 of the DSA challenge, and the question that we're going to solve today is rotate a linked list. So this is the question. Although this is a medium type question, but I would genuinely say that it's an easy level question. I mean, we have solved uh, more difficult questions than this, which were marked as easy, honestly. So yeah, this question is going to be fairly simple. So the question says that given the head of a linked list, rotate the list to the right of the of by k places. So I hope you have already done this question in what do you call it? In arrays, right? And this is almost the same question, but it is there for linked list. So if I just copy the image and paste it probably here, right? Uh, See, here we know that k is nothing but 2, right? Here, as you can see that k is given as 2. If you rotate it once, right? If you rotate it once, that means the last node becomes your head. And if you rotate it twice, that means your second last node becomes your head, right? So just think in that manner, okay? Now, what do you have to think? Okay, let's see. Basically, if I rotate it, let's just say, let's see, k can be any number, right? K can be greater than, equal to, lesser than the length of list. So it doesn't matter whatever the length of the list is, k can be anything. K can be literally anything ranging from 0 to what do you call? What is the given here? The number of a k can be 2 to the power 10 raised to power 9. So let's first analyze if k is lesser than, first case when k is lesser than length. Or okay, yeah, first let's see that. Then we'll see if what happens if k is greater than equal to length. Okay, that will be a second case. So let's analyze for the first case. Okay, if k is given to me as 2, right? And length is 5 here, as I can see, right? So I can obviously find the length. How I can find the length, that is something that I'll have to see. This is my tail, right? This is my tail while this is my head. I hope this is clear to you, right? Because 5 is pointing to nothing but null. So I can call 5 as my tail and head as 1 that is given to us. I can find where my tail is, right? I can say that, hey, whenever tail dot next is equal to, null, I can stop there and that will be my tail. So assuming that I have found my tail, so 5 will be my tail. Okay. In the first go, this should ideally point to head. If you can see in the rotation, 5 is pointing to 1, right? 5 is pointing to 1. That means pointing to my head. Okay. Now I need to find my new tail. What will my new tail after k rotations? Okay. Okay. I can probably think of that. So I have length as 5, k as 2. That means my tail would be nothing but 5 minus 2, that is equal to 3. That is if 1, 2, 3. This particular node will be my final what? This will be my particular final tail, right? After k rotations, this will be my final what do you call final tail? Okay. Now I need to somehow remove my head from here, mark it to this point, and this should point to null. I hope you understand, right? So I have found my new tail, right? This is my new tail. So new tail dot next will be my head. This is first step. Second step will be new tail will be pointing to null. Isn't this what this is? So, okay, 1, 2, 3, 4, 5, and 5 is pointing to null. Cool. This is what is given to us. Let's just say k is given to us as 3, right? And let's take a new one. Head is given to me as this, assuming that I have found my tail to be as my 5. Cool. What I'll do is my first step is to point my tail to my head. Okay, this is my first step. Now, what is my second step? Find my new tail. New tail, which is nothing but length minus k, which is nothing but 5 minus 3, that is equal to 2. That means this will be my new tail. This will be my new tail. Okay. That means now third step is point head to new head, right? What is it? It is nothing but new tail dot next. That is, this will be my head, right? This will be my head. What is the fourth and the final step? New tail dot next equals to null. That means this should point to null. What is my final output as? 3, 4, 5. 5 is pointing to 1. Okay. 5 is pointing to 1. 1 is pointing to 2. And 2 is pointing to null. Correct? Isn't this what is required? Yes. Very, very, very simple. Okay. Let's write the pseudo code for it. Pseudo code. Okay. So first, find the length. That will be my first step. Now, how will I do it? Length is equals to 1 and find the length and tail, right? So tail will be nothing but head. So while my tail dot next is not equal to null, right? I can say that, hey, length, sorry, tail is equal to tail dot next and length plus plus, right? So assuming that now I have my tail, right? I have my tail, I have my length as well. What will be my next step? I will say that, hey, tail, you should, uh, tail should point to null, sorry, to the head, right? I will say that, hey, tail, is tail dot next is equals to head, correct? This is my head. Now I will find, let my last end is nothing but length minus k. Length minus k, correct. Now comes an important part. If, why, I'll write this code later on, but first let me explain to you something. Let me explain to you something. Okay. What if my k is 20? K can be anything. K can be from ranging from 0 to 2 to the power 10 to 2 into 10 to the power 9. This is what is given to me. Okay. What can it be broken as? Can it be broken as 5 plus 5 plus 5 plus 5? So length, I mean 5, why am I dividing it with 5? I mean it is divisible by 2 as well. Why didn't I write it for 2? Basically, I am writing it in terms of length, right? So 20 is divisible by 5 completely. If any number is divisible by it, what if I rotate this by 5 times? What if I rotate this by 5 times? Will my head be this again? Yes. If I rotate it by 1, this becomes my head. Let me take a 1. If I rotate it with 1, just see my finger as well. Rotated by 1, 5 becomes my head. Rotated by 2, 4 becomes my head. 3, 3 becomes my head. Rotated by 2, 2 becomes my head. Rotated by 5, 5 becomes my head. Correct? 5 becomes my head. Oh, sorry, 1 becomes my head. If entirely when I have rotated it with a number with a k that is equal to length, that means this is the head that is given to me as an input will be my head again. Cool. So if it is rotated by 20, that means it is divisible by the length, right? That means it will again be the head only that is given to me. Cool. What if I am given 21? So it can be written as 5 plus 5 plus 5 plus 1. That means effectively I will have to rotate it one more time. That means 5 will be my head. 5 will be my head. So my k effectively becomes k modulus length. And people who don't know what modulus is, please read it on the internet. K is basically, modulus basically means that it gives you the remainder. So if I divide 21 by 5, that is length, what is the remainder of it? 1 is the remainder, right? If I 20 becomes divisible, right? So 1 remains. Let's continue with our code. So I will say that if my k modulo length is equal to 0, just simply return, oh, I think I should write it a little above. Yeah, here. If my k modulo length is equal to 0, return head, else do this thing. So k effectively becomes k modulo length, correct? Now what is the next step? Now I have found it. I will find my last node. How I can do that? I can simply say that, hey, just temp is equal, sorry, tail is equal to tail dot next. Now what is it? Where is my, okay, we'll try run later on. We'll try and rate later on, but just understand this. Okay, so I have found my tail. I will say that, hey, tail, head, you are nothing but what? Tail dot next. Tail dot next, please point to null and return head. Okay, let's try run this. Let's try run this. Cool. Let me, yeah, let me take an example. No, this should become green only. But if I take this 1, 2, 3, 4, 5, pointing to null. Let's assume k to be 30, right? K to be 30, no problem. Let's find the length and the tail. So length is 1 and tail is equal to head. So that means my tail is here as well as head is also here. Cool. So tail with this thing will be here only, and length would be equal to 5. You can just dry run it. You will find that length becomes 5 and tail is at 5 only. Cool. What is my k modulo length? My k modulo length is nothing but 13 modulo 5. It is not equal to 0. It is equal to 3, right? So this will not run. Cool. This will not run. Now this thing. So that means I will point it to this point. Cool. End is nothing but length minus k. Now what is length? 5 minus, okay, sorry, there is a problem in this point. Actually, this point should be written above this. K is equal to k modulo length, right? Now understand this. So what is k modulo? What is 13 modulo 5? It is nothing but 3, right? It is nothing but 3. So 5 minus 3 is equal to 2, is equal to 2. Cool. So I have found my head. Now, while end minus minus, so that means tail is equal to tail dot next. So tail comes here, end becomes 1, tail comes here, end becomes what? End becomes what? End becomes nothing but 0. And this loop will break. This loop will break. So that means my k is at this point of time. Now I will say that head is equal to tail dot next. So my head removes from being here and comes here. Cool. Cool. What does this say now? Tail dot next is equals to null. That means I will point it to this and return head. So if I return head, what is my head? Head is 3, then 4, then 5. 5 is pointing to what? 5 is pointing to 1. 1 is pointing to 2 and 2 is pointing to null. This is my answer. Correct? Let's now write the code. Cool. We'll discuss the time complexity later on. Don't worry. So let tail is equal to head, length is equal to 1. Okay. Find of list. Okay. So while my tail dot next is not equal to null, I will say that hey, tail is equal to tail dot next. Then I will say that hey, length plus plus. Cool. Now I have my length. Okay. Now I have my length. I will say that if my k modulo length is equal to 0, then in that case I will just return my head. Okay, cool. I will say that hey k, if that is not the case, then I will say k is k modulo length. Let end is nothing but length minus k, right? While finding the new tail. While my end minus minus tail is equal to tail dot next, correct? At this moment of time, when this loop has broken up, tail will be pointing to the new tail, right? Okay. So I will say that, hey, head, please be updated. So it will be nothing but tail dot next. And now tail dot next is nothing but null. And I will just simply return the head. Let's quickly run the code. Cannot read properties of undefined, of null. Okay. Oh, I have to point tail dot next is equal to head as well. Yeah, accepted. Actually, I forgot to do that. Point the tail to the head so that it comes hypothetically in the front, right? Okay, let's try to submit it now. Great, it is breaking. Oh, actually, the point is, I think we are missing on an edge case. So I think what I should do is, I can say that, hey, if head is equal to null or head dot next is equal to null or k is equal to 0, I can simply return my head. Just understand this. If my head is null, in this case, head is null, okay? If head dot next is null, that means there is only one element. That means that will be how can you rotate it, right? And or my k is equal to 0. That means I don't have to rotate it. I just simply return the head. Now can I submit it? And accept it, right? And accept it. Actually, this is an edge case that I was forgetting, and this is very important. This is very important, right? So yeah, by this we have let's first discuss the time complexity. Okay, I think I can annotate here, right? Okay, see, the point is this thing is taking big O of n for sure. This is running entirely. This is running entirely, right? And this while loop is also in the worst case taking O of n. Now, why am I saying that? Why am I saying that? See, what if my k is nothing but k, let's just say, is equal to 1. That means I'm almost entirely and length minus 1. That means I am traversing n minus 1 elements at the max, or at least. See, I am literally running all the last, uh, what do you call, the last node I will not be traversing, but in this while loop, I will be traversing n minus 1 elements. So this is also running entirely almost O of n. So this is O of 2n. I don't think I am using an extra time. So this is the time complexity, space complexity. Am I using any extra space? Am I using any extra space in this entire? No, right? So that means constant of. So yeah, this is this is literally the question, and I hope you understood this question. How can I delete it? Yeah. So yeah, I hope you could understand. Let's write the notes. First, find the length and tail of the list. Handle edge case where k modulo length is equal to 0. Point the tail to the head and find the new mm, tail. Tail new head becomes new tail dot next. New tail dot next is equal to null. Null. Return head. Sorry. Yeah. Let's save this and mark this as done. I hope you were able to understand this question, right? This was fairly simple. This was fairly simple. Just just do these 3-4 steps that I've told you, and you would obviously understand like how to rotate it, right? So yeah, we'll meet tomorrow with a question called clone a linked list with a random and next pointer. I'll see you tomorrow, guys. Thank you so much for joining in. Bye bye.